Hello class, today we're taking a look at some mixed tangent and chord properties practice. So in this unit, the primary thing that we're trying to do with circle geometry is use bits of information that were given in the question or the diagram to be able to prove other bits of information that we aren't given but that we need in order to solve the problem. So if we take a look at question 1, we are told that point O is the center of the circle. So let's go ahead and mark that the center of the circle is named point O. And we're asked to determine length x. And of course, length x is marked along here. And length x is really measuring the size of this chord that goes all the way across the circle. So let's go ahead and name some points to be able to describe this chord. And I'm just going to use letters A and B. So I want to know the length AB along that chord. We're of course told to be sure to justify any angles and lengths that are not marked. So to solve for length, I want to go ahead and create a right-angled triangle that involves the length that I'm looking for, or at least part of the length that I'm looking for. The first thing I notice is that my chord is marked to have been split up into two parts by this point here. And that point there is connected to the center of the circle by a straight line. So by my chord property, I can conclude that there's a 90-degree angle here, because if a line bisects a chord, it cuts the chord into two equal parts, then it must be perpendicular to the chord, and that's what our chord property says. So let's go ahead and state that. So what line is doing the bisecting? That's line OM. And what chord is being bisected? That's chord AB. And by our chord property, we can conclude that those are perpendicular. So we're going to say OM is perpendicular to AB. If you wanted to, you could say the angle AMO is 90 degrees, etc., etc. That's fine. So that's given us a right angle there. And the reason that I want that right angle there is I want to make a right angle triangle that includes part of length x. I did have this right angle already given to me, but there's no triangle that I can create that includes length x. I could create that triangle, but I'm not looking for that blue line. So let's instead connect A to O, and that'll make a right angle triangle where we're looking at part of that triangle being length x. Now, in this triangle, I know that side MO is 3 units, and I also know that this blue line is 5 units because it's a radius, and this radius over here was also marked as 5. So let's look at that triangle. We're going to look at triangle AMO, and it looks like this when we draw it in a simpler way. We got our A to O is 5, our radius, our M to O is 3 from the question, and then we don't know what this side is up here. Okay, so let's go ahead and solve that triangle by our Pythag. In this triangle, the 5 would serve the role as C, B would be 3, and I don't know what A is. And you might recognize that this is a Pythagorean triple, but let's solve this out either way. And of course, we can conclude that our question mark is 4 units long. So to finish up, we're going to go ahead and observe that the length x is equal to AM plus MB, this length plus this length. Okay, and those lengths are both marked as 4 because they're marked as being equal to each other. And so we can conclude that x is the length 8 centimeters. So keep in mind the red part of my work here is the grade 9 circle geometry part. It's using the properties of the circle to fill in enough information to do the question. The blue calculation is really grade 8, but I can only do that grade 8 calculation once I have the right angle. I didn't have the right angle to begin with. So the grade 9 part here, we really want to make sure we're able to describe our chord properties or our tangent properties to be able to work the question. So in question 2, we got point O is the center of a circle. We want to determine the length x, and we want to be sure to justify any angles and lengths that are not marked. So what I see here is that I see we have a line that's outside the circle, and this line A to C, and this line touches the circle once at B. And for that reason, we can say that our tangent, which is A to C, A tangent line is a line that touches a circle once, and A to C touches a circle once, is perpendicular to the radius OB. And that's what our tangent law says. Our tangent will be perpendicular to a radius at the point of tangency. Okay, so we can go ahead and put in that right angle there at ABO. From here, we can go ahead and set up the right angle triangle, which is also ABO. And for that right angle triangle, we have this situation here where we know, that this is A, B, and O. We just figured out our right angle. We've got our 7 and our 5. And I'm going to figure out the whole distance from A to O first. So let's solve for that. Again, we're going to apply our Pythag here. In this case, the 5 and our 7 are our legs, so they go in the A and the B spots. C is our unknown. 20 plus 40 is 60. 5 plus 9 is 14, 74. And so our C will be equal to the square root of 74. I don't know what that is off the top of my head, but let's approximate it using our calculators. About 8.602. Okay, now that's the length all the way along A to O. So that's our length, that's 8.602 that we just figured out. Now for our x, let's go ahead and mark this point here as point M. And I'm going to use green for that. And let's say that OA is equal to OM, part inside the circle, plus MA, the part outside the circle. OA we just figured out, that's our 8.602. Now O to M is a radius, so I know that O to M is the same as my 5, that's O to B. And M to A is my x that I don't know. Solve this equation, I'll subtract 5 from both sides, and I'll get 3.602 is equal to x. And I think we're asked to round to the nearest tenth here, so we'll go ahead and say 3.6 is the value of x. All right, in number 3, we're told that a circle has a diameter of 10 centimeters, and that's what they're showing us here in the drawing. And we have a chord that's drawn a distance of 2 centimeters away from center. The key word here is distance. A distance is always drawn at a right angle or measured at a right angle to the thing you're measuring. So if we're measuring our chord, and we're saying that chord is a distance away from center, then we want to go ahead and make a right angle with our chord to connect it to center. And that's going to be our distance of 2 centimeters. Okay. Now the other thing I know is that if I have a whole diameter of 10, then I know that each half of that diameter is 5. So I can go ahead and mark those in. I'm also just going to label some points here on my diagram. And again, the letters that you use for this really don't matter. So we've done part A. We drew the distance as I was told to use blue. Well, that's fine. Through the magic of editing, let's go ahead and make that blue. Lovely. Not that it really matters, of course. And then we want to know how long is the chord. So let's start by looking at a right angle triangle. For the triangle that I have here, I have triangle ABC. And it looks something like this. We've got our 2 that we just figured out, our 5 on our radius, and our right angle at corner B. So let's go ahead and solve that triangle with Pythag to solve for length AB. In this case, our 5 is serving the role of C, it's across from the right angle. Our 2 is serving the role of B, and we don't know what A is. So A squared plus 4 should be equal to 25. We're going to subtract 4 from both sides and get A squared is equal to 21. That tells me that A is the square root of 21, and let's approximate that as 4.582. Okay. Now, that length there is also could be called the length AB. And so I know that this length here is my 4.582 that I just figured out. Now, I don't want just the length A to B. I, in fact, want the whole length from A to D, the whole length of the chord. And to do that, I'm going to have to prove that our A to B is actually the same as the length B to D. And so this is where my chord properties come in. By my chord property, I know that any line, so let's call our line BC here, is perp to the chord AD. Any line that's perpendicular to a chord is going to bisect the chord. And what that tells me is that the length AB on one side of that line must be equal to the length of BD on the other side. Now, I do know that the entire chord is equal to those two lengths added together. And since both of them are the same, and we know AB is my 4.582 that I figured out earlier, I'm going to add that together, or double it, that would be fine as well. And that gives me that AD is my chord, and it is 9.165 centimeters. And again, we're going to round that to nearest tenth per the instructions of the assignment. So we'll go 9.2 centimeters for the length of chord AD. Now, in your multi-step problems, often you do need to do more than one calculation. And often you're going to have to draw in some extra things after you've figured out some of the things that you know. This might take a few attempts, so have your eraser handy. You might need to add some lines, figure out those lines aren't helpful to you, get rid of those lines, etc., to be able to work your way through. So let's start in this question just by throwing some letters onto our drawing here. So I'm just going to label any unknown point. That's already O, so we'll go E over here. And we're again told that point O is the center of the circle, and we want to determine length X. So X is the length along the chord AC, so we should be looking to work along the chord A to C for our, for our answer here. So let's take a look at what we know is going on here. I do see that I have a different chord, C to E, and that chord is being bisected by this line here, which is O to D. Any chord that's being bisected by a line must be perpendicular to that line by our chord properties. And the reason that interests me is that this line here is a radius, and radii are often very helpful in questions because we can draw a radii in going to any other point, and all those radii will be the same distance or same length. And so I'm going to go ahead and first off show that I have this right angle here at point D. I'm going to use the right angle triangle to solve for the radius, and then I can use the radius over in another triangle to solve for part of side X. So let's start by saying that our line OD bisects the chord CE, and that tells me that it is perpendicular to that chord. And so we've got our 90-degree angle in there. Next, we're going to go ahead and solve the right triangle that we've just created. So that triangle is ODE. And let's solve our Pythag for that triangle. Triangle looks a little bit like this. And let's solve it out. Our 8 and our 6 are legs of this triangle. You might notice we have a Pythag triple here, and we conclude that 10 is the radius of the circle, which is, of course, the same all the way around the circle. Now, in these multi-step things, it might be helpful to kind of number your steps. So first thing I did was get the right angle. Next thing I did was solve the right angle triangle, ODE, for the radius of the circle. Next thing I'm going to do is look at another right angle triangle. So if, for example, I look at this triangle here now, and that is triangle, let's call it BOC. That is a right angle triangle, so I'm going to go ahead and solve for the unknown side in that. Oops, sorry, this is 10. Let me just figure it out. And I'm going to solve for this side of that triangle, which is part of the x that I want. So let's go ahead and do that. Oh, and we got a right angle in there as well, which was given to us in the question at corner B. All right, so let's solve that out. And we'll do our a squared plus b squared is equal to c squared. In this triangle, the 10 is the c. We'll call 3 the b. And I don't know what a is. We'll get a squared is equal to, what, 91 after we subtract 9 from both sides. And so a is equal to the square root of 91. Let's approximate that. Is 9.539. Okay. Now the final thing is to solve the problem, I need to be able to show that a to b is the same as b to c. And then I can just double my 9.31. Now to do that, I again want to go ahead and observe that line BO is perp to chord AC, and that tells me that it bisects that chord, and it cuts it into the equal lengths A to B and B to C. Because of that, I can go ahead and say that the overall AC is equal to 2 of my BC, and I figured out that BC is my 9.53, and so we'll double that, and we'll get that X, which is AC, is equal to 19.07, which is 19.1 centimeters. Oh, I guess we actually don't have units here, so that's okay. So, good example of kind of working your way around, figuring out different things, using those different things in other places as we continue working towards our solution. In these multi-step ones, very rarely, obviously, you're going to be able to just go right to the number that you want. You probably have to do some other work first to figure out other things that are useful. So let's take a look at question 5. We're told that if point O is the center of the circle, we want to determine x. So let's take a look. First thing I'm going to look at is this line here. This line is outside the circle and touches the circle once at point E, and that tells me that it is a tangent line. Now, why is that helpful? Well, a tangent line always forms 90 degrees to the radius of our circle, and so I'm going to go ahead and start by putting in that angle there. So let's go ahead and say that as our first thing, we have line ED is tangent to the circle. And we can go ahead and say, therefore, angle OED is 90 degrees by our tangent law. Okay. Next thing I'm going to do is I would like to find the radius of the circle. And I have a line here that goes between the outside edge and the center of the circle. It is split up into 2 parts, but I can go ahead and add those 2 parts together and say that my radius is 5. Now what that means is that any radius of the circle is also 5, so I know that O to E is also 5 because it is a radius. The next thing I'm going to do is I'm going to solve for the length of this line here, O to D, and to do that I'm going to look at the right angle triangle that involves that line, which is this guy here. So let's go ahead and look at triangle OED, and let's go ahead and solve the Pythag for that triangle. We got our right angle, we figured out that's 5 from the radius, and this is 10 from the diagram, and let's figure out that side there. In this case, our 5 and 10 are legs. This is going to be 125 total, and so we'll square root 125 to get C. And that is, I don't know, 11.18. Okay. So we can go ahead and fill that into our diagram. All the way along this guy here is 11.18. Now, next thing I'm going to do is I'm going to look at our, what color should I use for this? Let's use orange. I'm going to look at this triangle here, which involves the length I'm looking for finally. This triangle here has a right angle given to us, so that's good. And it has 2 sides that we know. We know the 3 already from the question, and then we just figured out our 11.18 there along the hypotenuse. So let's go ahead and solve that triangle for its unknown side. So this is triangle OBD. And let's do our Pythag. A was 3. I don't know what B is. C was about 11.18, but I actually know that that was square root 125. So I'm going to use that exact value there, because when I square that, it just gives me exactly 125, which is the exact correct answer, no rounding. We're going to get b squared is equal to, what, 116? And so b is equal to the square root of 116, and that will approximate as well, 10.77. And really, this is line BD. Okay, so we got this whole thing here is the length 10.77. We only want part of that length, which means we need to subtract off this piece here. Now, to be able to get that piece there, I'm going to notice that our line, what are we on? We got 2 number 2s. Perfect. This is actually step 3. So let's go to step 4 over here. And let's observe that our line OB is perp to chord AC. And that tells me that that line bisects the chord. And we can say AB is equal to BC is equal to 4. Now, that didn't have to be step 4. We could have done that right at the start. But it is helpful right now to go ahead and say that these 2 lines are the same length by our chord property. Now, lastly, we're going to finish up. Running out of colors here. Last thing I'm going to do is figure out my length x. I'm going to say that my overall line B to D is equal to BC plus my CD. BD I just figured out a minute ago was 10.77. BC I just figured out is 4. CD is the x I want. Let's subtract 4 from both sides. And my 10.77, take away my 4, leaves me with 6.77 as the value of my x. Okay, so definitely quite a bit of work in that question, going between all those different values there for our work. Okay, so I hope that has helped you with identifying different chord properties, communicating those chord properties, keeping our work reasonably neat, and being able to, again, communicate our circle geometry parts of the question, as that is the grade 9 topic.